Welcome to another video of Monocle Maths. We'll be going through the GCSE 91 specification for mathematics, and today's video we'll be going through the topic of numbers, specifically looking at the lowest common multiple, also known as the LCM. This topic does apply to both the higher and lower tier. So, what is LCM? LCM stands for the lowest common multiple, or it is the smallest number that is a multiple of all the numbers in a question. So, like many of the things in maths, it's best explained and shown through an example. So, if we look at this example, what is the lowest common multiple of 5 and 8? The first steps to answering this question is going through the multiples of each of those numbers. So, let's list out the multiples of 5. We have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And you can continue going on and on forever. Now, let's list out the multiples of 8. We have 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and we can continue on and on. So we've listed the multiples of 5 and we've listed the multiples of 8. Now, if you look at this, what are the numbers that they both have in common in the list that we have so far? So we know that 40 is common. They both have 40. And they also both have 80 at the same time. So in our current list, we have 40 and 80 are common multiples. So 40 and 80 are common multiples in this list. But our key here is to focus on the lowest common multiple. And the lowest in this list is 40. Therefore, and for those of you who don't know, this triangle dot means therefore. 40 is the lowest common multiple. And that would be our final answer. Now, 80 is also a common multiple, but it is not the lowest common multiple. Effectively, any two numbers could have infinite number of common multiples, because if you were to list 5, all the multiples of 5 continuously, it would go on and on forever. It would go all the way up to 500 and maybe 5,000 and so on and so forth. And the same with 8. 8 could go up to 800, it could go up to 8,000 and so on and so forth, all the way up to infinity. And they'd have more and more multiples in common as they keep getting bigger and bigger. So there will be infinite number of common multiples between any two numbers. But the whole point of LCM, the lowest common multiple, is the fact that you are looking for the lowest value between the two. The lowest valued multiple between the two. So in this case, between 5 and 8, the LCM is 40. Let's look at another example. What is the lowest common multiple, or the LCM, between 6 and 10? The method that I prefer to use is called the grid method, in which we have to start off by drawing two lines in the shape of a cross, and on the top right side we would write the numbers 6 and 10 respectively, or any numbers in which you are looking for the lowest common multiple of. Put them next to each other on the top right hand side, leaving space on the top left side and on the left side in general to write any of the numbers as well. The aim of this method is to convert the numbers 6 and 10 into prime numbers. That's what we're aiming to do. So essentially, we're looking for the prime factors of 6 and 10 to write on the top left side of the grid. Now, looking at the numbers 6 and 10 and looking at the prime factors that they have, there's only one number that comes into mind, and that is 2. That's the common prime factor that they have between the two numbers. Now we divide 6 and 10 by 2.
So 6 divided by 2 gives you 3. And then you would write 3 underneath 6. Then you'd do 10 divided by 2, which gives you 5. You would write 5 underneath 10. So now you'll notice that we are left with prime numbers 3 and 5. And obviously, there is no common prime factor between other prime numbers, and that's why they're called prime numbers. So you cannot divide 3 by any other number other than itself and 1. You cannot divide 5 by any other number other than itself and 1. So this is where this process stops. So now we will select all the prime numbers that were involved in this whole process. So we select 2, we select 3, and we select 5. Now all the prime numbers, including 1, if there is 1 in the process, because if you divide a number and it turns into 1 at some point, have to be multiplied. So therefore in this case we have to multiply 2 by 3 by 5. So 2 times 3 times 5, which gives us 30. Therefore, the lowest common multiple between 6 and 10 is 30.
So another example, if we deal with slightly bigger numbers now, what is the lowest common multiple, or the LCM, of 28 and 42? So again, if we were going to solve this through the first method of listing out all the multiples of each of those numbers, it's going to take quite a long while and it's going to be quite complicated, because 28 is a big number, and as you keep looking for multiples of 28, you're just going to get into bigger and bigger numbers, and same with 42. And it's a lot more difficult to try and find the common multiples between those two lists. So again, this is where the grid method is the most efficient way of finding the LCM. So we're going to solve this using the grid method. So I'm going to write 28 down and 42 down. So we're going to divide it by the prime numbers. 2, that will give us 14, because 28 divided by 2 is 14. And now 42 divided by 2 gives you 21. Another prime number that I can spot here is 7. 7 seems to be a common factor between 14 and 21. 2 and 3. Now these two are now both prime numbers. 2 is now a prime number, 7 is now a prime number. So those are all the prime numbers now. Now we do 2 times 7 times 2 times 3, which equals 84. Therefore, 84 is the LCM of 28 and 42. And that is our answer. Now let's try and look at the LCM between 69 and 420. So again, the grid method is the most efficient way. We're going to put 69 and 420. Now let's look at the difference. So immediately, we can't quite divide by 2. 2 isn't going to work because 69 is an odd number, and dividing an odd number by 2 won't give you a whole number. Let's look at 3. We'll try 3. So 69 divided by 3, you'll know, is 23. And then you could do 420 divided by 3, which would then give you 140. Now we're at 20 at 3 and 140. Now, here's the thing, 23 is actually a prime number. There is no factor of 23 other than 1 and 23 itself. So you've successfully changed this number into a prime, 69 into a prime number. 140 is not a prime number yet because it's still an even number, and the only even prime number is 2. So now that we've dealt with 23, we circle it, we are done with it. We can't divide it into anything. So now we're just focusing on the 140. So because 140 is the only number involved, you would essentially just want to change it to 140. You want to divide by 140. You'd want to divide it by 140 because remember, the goal is to change those two numbers, 69 and 420, into either a prime number or the number 1. Okay, if you can. And because 140 is the only number left, it could only turn into 1, really. So you can divide that by 1. Now remember, we've circled 23 already, so you can't do 23 divided by 140. That remains 23. You don't continue with that list anymore. Now down to that side, this column, 140, you want to divide that by 140, and you get the value 1. And that's the end of that process. So now you circle all the numbers that are involved, the prime numbers and the numbers in which you divided by involved. So now you have these two numbers. So now you want to multiply 3 times 140 times 23 times 1, which would then give you the value of 9,660. So therefore 9660 is the LCM of 69 and 420. Now imagine if you use the first method of the column of listing out all the multiples of each of those numbers. If you listed out all the multiples of 69 and 420, it would take you ages to reach that number, or even to realize that 9,660 is the first common multiple between those two numbers. It'll take you ages, which is why the grid method is one of the most efficient methods of finding out the answer. So that's it for today's video on the lowest common multiple. If you have any questions about anything else, or if you want me to cover anything more on lowest common multiples, do let me know down in the comments below. Don't forget to like if you found this video helpful, and subscribe for more numbers content, as well as any other mathematical GCSE maths content as well. Thank you for watching.